Hello, everybody, and at long last, we're going to finish off our 2019 Grade 8 Gauss. As we're looking at the last question, question number 25. In quadrilateral PQRS, diagonals PR and SQ intersect O. And they're telling me that O is inside PQRS. Okay, fair enough. SP is the same as SQ, so these lengths here are all 1, they're telling me. Okay, so I can already see, you got an isosceles triangle here in case we're going to do some geometry. It looks like we're going to do some geometry, but we'll see. And what else have we got? Angle QSR, this angle here, is twice angle QSP. Mark determines the measure of the 12 angles that are the interior angles of each of these triangles, all the ones involving O. Yeah. Okay. The measure of each of these angles in degrees is a positive integer. Okay, no fractions, no irrationals, nothing. That's fine. And exactly 6 of them are prime numbers. Well, that's interesting. You don't really see prime numbers in geometry happen a whole lot. That's just angles, I guess. How many different quadrilaterals have these properties and are not rotations or translations of each other? Okay. So it might be a good idea to start looking at the angles here. Seeing what we can see, seeing what we can simplify. So let's draw a picture here. Try and make these lengths sort of the same. Close enough. So these were all 1. Actually, you know what? These ones I'm going to give a special color so I remember that I know they're the same. Because isosceles triangles and angles, I feel like there's some work to be done there. And I also want to draw a bigger picture because I feel like we're going to do a little bit of diagram chasing at the start here. Chasing a lot of angles around. I'd like to have space to write angles. Okay, P, this was S, so Q and R are here. Now the angles they're talking about are these ones. So these are the 12 angles that Mark was looking at. Okay. So what can we see? Well, we know that maybe we call this angle X. This angle here is 2X. Now, thinking ahead to our prime numbers, could 2x is even, could it be prime? Well, only if x is 1. But just because my picture doesn't look like this is a degree of 1, doesn't mean that's not possible. So it's definitely something to think about. But if x can't be 1, then this definitely is not one of my prime numbers. Okay, now what have we got here? I don't really see any other immediate things we can. So suppose we could put a y here, and then this is 180 minus y, and opposite angles of a intersection are the same. So this is 180 minus y. We get another y there. With both of these, we can figure out this angle. So 180 minus y minus 2x. And this one here is y minus x. Okay, what about these angles in these back triangles? So here's where I think we can use the isosceles. Before we jump to those, I can see something because PSR is an isosceles triangle. These two angles are going to be the same. So 2y plus x is equal to 180. So let's write that up here off to the side because we're mostly done with the triangles on this half. Right, x plus, yeah, x plus 2y. Okay. All right, but we do have some other isosceles triangles. So these angles here can be worked out. Anytime you've got an isosceles triangle and you have sort of an angle up here, these two are the same, and they're both 180 minus that angle, the apex angle, over 2. So this one in here is going to be 180 minus x over 2. This one down here in this triangle, the apex angle is the non-isosceles angle, or the non-equal angle, is going to be 2x, so we get 180 minus 2x over 2, which can simplify to 90 minus x, which is quite nice. What else can we see here? And then this angle here is also 180 minus x all over 2. That's the green one, but then we subtract off y minus x. And this big angle here is also 90 minus x, but then this angle in here can be worked out. So let's work those angles out. So subtract, say 2x over 2. Oh no, it's y minus x, so minus y minus x. So this turns into, when the brackets drop, plus 2x, and so minus x plus 2x, it'll be 180 plus x over 2 minus y. So that's what this angle in here is. So 180 plus x all over 2 minus y, whatever that is. Okay, and then it looks like everything can be determined just in terms of our x and y. And then this angle down here is going to be 90 minus x minus 180 minus y minus 2x. Drop the minus sign and turns into a plus x and a plus 2, or plus y and a plus 2x. So it'll be x plus y minus 90. There we go. So that's what that angle down there is. We get rid of these green angles so we're not so confused. Get rid of our calculation here. So we can divide by 2 and got the 90 minus x here, which is quite nice. But this one here, for example, 180 minus x all over 2, we weren't able to simplify that, but we were told in the question these angles are all positive integers. So 80 minus x must be even in order to divide by 2 and get a positive integer. 180 is even, so x must be even. So we could do something like let x be 2w. Right, and then 180 minus 2w over 2, that's going to be 90 minus w. And so 90 minus x, no, that's 90 minus 2w. And this becomes 2w plus y minus 90. And this would be minus 4 w. Although we said that these were the same, so let's just call it y minus x. Except now we can call it y minus 2w. This one here becomes 4w, and so now I know for a fact this one here is not one of my primes, because multiples of 4 are never prime. This is 2w. The 180 plus 2w over 2 minus y is going to turn into 90 plus w minus y. Okay, and then this y minus x turns into y minus 2w. So it looks like the angles are a choice of w and y, so pick those. Now that's going to be kind of hard to deal with, isn't it? Is there another any simplification that we are missing here? So we'll add the definition of w to our list so that we don't forget it. So let x be 2w. I suppose now we could reevaluate this. 180 is 2w plus 2y. So divide by 2, 90 is w plus y. So that's a better fact. And I guess actually then that means that we can get rid of one of these. We can get rid of y or we can get rid of w. Let's get rid of y. So y is 90 minus w. So now we embark on a long journey of trying to get rid of the y's. Do that really easily in here. These are 90 minus w, which we already had one of those. So I guess we've got another hidden little isosceles triangle in here. Not that we're particularly concerned with those, but we've got 390 minus w's. Well, that's going to sort of simplify the things when we look for primes, because we're only going to get so many angles. 180 minus y is going to be 90 plus w. So we get 90 plus w's in here. What else? Okay, down here, the y, so we get 2w plus 90 minus w minus 90. Well, the 90s will cancel out. So it looks like this is just w. Yeah, okay, that one's just w. So now we don't need that one anymore. Where else do we see a y? So these two are really the only ones left. Yeah, I know there's this one, but it's a carbon copy of this one. So 90 minus w minus 2w. So these are 90 minus 3w. And then it will just matter what w is. Now, notice you can take out a factor of 3 here. Just like I guess you could take out a factor of 2 over here. Unless, of course, w is 44 or 29. So, things to think about. And then this one up here at the top. So 90 plus w minus y, except y is 90 minus w. So the 90s cancel out. Minus, minus. So this is going to be 2w up here. Okay. Oh, look at that. No, this was called O, I think. So OPQ is congruent to QSP. That's kind of cool. We don't really need that, but that's kind of cool. So we only have so many angles. We've got 1W. We've got 2 copies of 2W. Let's just check them off. So the 2Ws, got 1W. We've got 1 copy of 4W, which will never be a prime. 2 copies of 90 minus 3W. Let's do the 90 minus 2W now. We've got 190 minus 2W, 390 minus W's. And then looks like 2 remaining copies of 90 plus W. All right, 4, 6. Yeah, okay, that all adds up. Nice and neat. Okay. So, what can we do? Well, we've remarked a few things as we've gone along. What if W is 1? What if W is 44? What if W is 29 to make certain things prime? So, for example, this is 330 minus W. This is 2 times 45 minus W. And this one here tells me that W has to be less than 30. That's kind of cool. We'll add that as a little fact down here. W is less than 30. Okay. So what if W were 1? Well, you'd get 2 primes in the form of 2. You get a 4 here. This would be 3 times, so you get 89, 3 copies of 89, that's a prime. 91's not a prime. 88 certainly isn't a prime. And 87 is not a prime. Okay, so it's a multiple of 3. So W can't be 1 and have enough primes. You get 2 of them, 5 of them, but the rest are not. Okay, so we can't have 1. What about the 29? Because that would make this 3, and 29's a prime, so that's 3 primes already. Now, if W is not 1, this isn't a prime. This one never would have been a prime. So we don't even need to calculate those. This will be a multiple of 2, whatever it is, because we're not looking at 44, and we'll never look at 44. So we're running out of things that can be prime. We've got 3 of them already. 90 minus 29 is going to be 61. Well, that's 6 primes. And 90 plus 29 is 119, which is 7 times 17. So W being equal to 29 certainly works. So we could have that little case there. Actually, I suppose we could just run through... Well, there's a lot of numbers less than 30, so maybe we can narrow things down. Now, if W isn't 29, which definitely does work, so let's say W equals 29. That's a possibility, so that's at least 1. Although we should expect at least 5. So we definitely have more work. But if W isn't 29, then this term in here isn't 1, so this thing isn't 3. So it's going to be a multiple of 3 for anything other than W equal to 29. So we're not going to get any primes there, and then there's only going to be 1, 4, 6 left. And since we have to have exactly 6 primes, that means W must be prime. And that narrows things down even more, so we might even be able to make a little chart. W can't be 1, but it could be 2, 3, 5, 7, 11, 13, 17, 19, 23. It could be 29 again, but we already did that one. And that's it for primes less than 30. And what are our other possibilities? 90 minus W and 90 plus W. These have to be primes. So for 2, the next one isn't a prime, so don't even bother. For 3, not a prime, don't even bother. 5, not a prime, don't even bother. None of the factors of 90 would help us here. None of the prime factors. 97 is a prime, and 83 is a prime. So there's another one, so now we're up to 2. 90 minus 11, that's 79, plus 11 is 101. Those are both primes. So that's 3 scenarios, 3 cases. 90 minus 13 is going to be 77, which is a multiple of 11, so that one doesn't work. 90 minus 17 would be 73, that's a prime. 90 plus 73 would be 107. Also a prime. Very, very quick to check if these are primes if you know your primes off by heart. If not, you're going to have to grab a calculator. I know sometimes we forget, 101, 103 are those primes. So it might take you a little while to look them up or work them out, but I've seen so many primes, so many small primes, that this is going fairly quickly for me, which reemphasizes my point. You might want to know some of your primes, the first 25, the first 30 primes. 90 minus 19 would be 80, no, 71. 71 is a prime. And then adding it on would be 109, also a prime number. So there's our 5 cases. So the answer is at least 5, but the question is 23. Will you give me another case, or are we getting an answer of 5? 90 minus 20 is 70, minus another 3 is 67. That's a prime. And 90 plus 23 would be 113, also a prime. So there's 5 cases, and then there was the 29 as well. So that's a total of 6. Of these quadrilaterals. So, looks like our answer is going to be D. And there we go. And that finishes off our 2019 paper. If you're looking for more grade 8 Gausses, feel free to browse around the channel. If you're looking for something a step up, feel free to try some of the Pascals. Those are grade 9 level contests, but very same format. And either way, I will see you for more math in the future. Take care and have a wonderful day.